Login accepted.
All right, I think that's enough time for everyone to sign in. Unfortunately, the camera isn't working in the room, so you can't see us on Zoom, but you can hear me, so it's fine. What goes first? Oh, okay. Give it to Marshall.
So my name is Marshall. I'm again fourth year CE. For CCDC, I'm the threat hunter. CPDC, I'm the captain. You've kind of already heard this for probably week one, so nothing much else to say.
I'm Bill. I'm a fourth year CIS student. As for competition teams, I was the Linux web and database guy. And I was in NCAE in spring 23. As for Swift, I'm currently the co-president with Sydney, and I'll be teaching some Linux with Marshall today. Well, we're here at Linux Week. Next week is Windows, and then on August 17th is services. And then August 31st to September 1st is tryouts. So you have a few more weeks left. All right, so first section will be about, yeah, how are we halfway done? I don't know. How's it already August? So first section is Linux basics. Second section, Linux admin, general sysadmin business. Third section, we'll go over Linux security and networking. Yay, more networking. And then fourth section is firewalls. Yes, quote unquote networking. All right, I'll start off with some basics. What is Linux? Often people refer it as an operating system, but really it's not really. When we say Linux, we're actually talking about the Linux kernel. That's basically a component where it communicates with the hardware, communicates between the hardware and the software side of an operating system. But when people like mention about different types of Linux or different OS of Linux, they're mostly referring to the different distros or distributions, or also they call it the flavors of Linux. And that's you see right here, your Ubuntu, your Kali, your Arch Linux, and Red Hat. So those have different like applications or different front end stuff, but fundamentally they're still running the same Linux kernel. And then Linux is built on, or Linux is built to be similar to Unix, or the Unix kernel, which other Unix kernels include macOS. And the difference is, yeah.
Yeah, Unix is quite old. I think it was created by Bell Labs. It's a very old thing, but a lot of current Linux is built off of Unix. And other things you might be familiar with, Mac and BSD are also built off of, or are close, I think they're closer to Unix, but I'm not too sure. All of it focuses on Unix.
Linux was named after an actual person.
Yes, Linus, I don't know his last name, but Torvald. Yeah. But yeah, Linux is free, so just use that. Kind of went over this, the different layers. It's kind of like lasagna. You have your hardware, your CPUs. Let me turn on the laser real quick. I like the laser. You have hardware, CPU, RAM, all that stuff. Then you have your kernel. Right here we have the Linux kernel, but there's also the Windows, I think it's NT, or Windows NT kernel. Shell. What a shell is you often see it as the terminal, but it allows you to interact with the kernel through commands and other applications. And then applications, it's your specific programs that are meant to provide a feature or a service. So that's basically the lasagna of OSs. Why is this blank? Oh, wait, no. So speaking of shells, I mentioned terminals. Nowadays, we have more like software-based terminals, or we call terminal enumerators, the emulator, my bad. But back then, terminals were more like specialized equipment. We don't really see them anymore, pretty old. But nowadays we have emulators that do the same thing as terminals, and you'll most likely use those, or not most likely, you will use those. No one has a hardware terminal anymore, but you'll see how you can interact with that terminal. And then in Linux, there's not just to Linux, but there's also like a desktop version where you can enter the terminal, but there's also a server version where there's no interface, graphic interface. So everything that you interact in that OS or version is all terminal based. So it's a great skill to have to learn how to use a terminal, and we'll go further into what kind of things you can do with the terminal. So the next is how the file structure goes is more, everything is either a folder or a file. So, sorry. So at the very top, we refer that as the root. That might be something like in Windows comparison would be like a C to C drive at the very top. Here we just have a backslash or a forward slash here. And then under that we have like your main files here. So I'll go to them one by one. Not all of them, but first we have the boot folder or boot directory, where it's any data that is launched before the kernel begins to execute user programs. And then we have the Etsy directory. Why is it called Etsy? I don't know, but yeah, etc. But even though it's called, etc., but it's probably one of the more important directories, I would say. That's where your configuration files are. You'll most likely mess around with this directory, I say most of the time. And then you have your proc directory. It's where your process information is stored as a file. You could view what the information of a process, and you could like view, yeah. And then you have dev or devices. This directory is meant for like USB drives or whatever is attached to the computer. So it's where you check on those devices. Home directory, that's where like normal users, I'll go into users later on, but that's where their home directory is. That's where most likely when you're using a Linux, when you're using the terminal, that's where your users most likely will be, and where you will place when you log in. And then you have the root directory, which is the root user directory, home directory. Then you have var. That one is more, I would say more temporary. Yep. Yeah. It's yeah. So whatever is like modified for applications and stuff like that, you most likely go into that directory. So most of the time you'll see logs in there, but also that's where most of the web servers put their web root and all their website files inside. And then for user, that's mostly where applications and utility executables are located. That's where like bin and sbin is, where if you type in the command, it will most likely go into that directory and find the executable. And then temp, just temporary, as the name stands. It's mostly for storing stuff temporarily, and then usually it gets erased like after reboot, I would say. And then mount or MNT, it's for like file shares. If you decide to mount it onto your computer or your device, it's just to access like a network file share or a different drive, or yeah. And then OBT is, I would say it's kind of like the same as bin and sbin, but not really. It's just kind of optionally there for other applications to use. All right, so then next we have paths and directories. There's two ways to access like directories. There's the absolute path, where everything starts, every time you start the path, it starts with the root. So it's basically like your full address to that area. So if you see right here, it'll be like slash, so then the root and then home, and then wherever you want to go. So it all with a absolute path always starts with a /. And also note that each slash right here indicates a directory. So then whatever is in here is in the desktop directory. And then relative paths are more like whatever directory you're in, you can access the files there. So you don't have to put in the full path, like this one right here. If I was in the command line, if I had a file that's named script.sh and I was already in let's say it's in this desktop directory. If I'm already in that directory, I could just like access that file with just typing script.sh. So that's what a relative path is. And then there's other various ways to like navigate through directories. You have a single dot, which you're not really navigating. You're kind of just going back to the same place. It just indicates that like your current directory. And then for going back to the previous directory, it's with two dots. So sometimes you get an interesting way of going back to directories with a two dot. Yeah. Is there a question? I didn't mention this earlier, but there's a CD command. The CD command, helps you navigate through directories, and it's pretty simple. You just put in the path and you go there. And then for root, or explain like different roots when we say root. First, we have the root directory, which I mentioned was the very start of the file structure. And then we have slash root or root, slash or root. No one calls it root, but I call it slash root. It's the root user's home directory. And then you just have root, which is the root user. I'll go more into root users later, or the root user later. But now we'll go more into command syntax and kind of like how to use your first command. So the syntax of the commands is always starts with the command, but also it follows up with either options, which are like different ways to use, or different like
different flags that represent other options.
yeah, so we call them flags as well, but there's different ways you could view or use the command. But then for arguments, I would say it's more important because that's how you actually use the command. Like the CD command that we talked about. It's the CD command, and then the argument is also the path that goes to. But we also the ls command is more for listing files in a certain directory, and they have different options that you can use. You could either, so when you use options, it starts with attack or a dash, we call it attack. And then you can start listing your options. You could use, to use multiple options, you could do separate. So it'd be like, for this one right here, it'd be tac L space tac A, or you can combine them. Or you can also use the full name of the option, but I don't think you want to. I don't know if you really want to type out the full name. Probably better to use like the combine thing. Like I mentioned, viewing files, ls. Oh, there's a question here. What's the difference between single tac and tac? Single tac is more for the short flags. So it'd be like the tac L here or tac A. That's how you specify it's for like, it's to indicate that it's for the short flags. And then double tag is used to indicate long flag. So then
Actually, really long flags for LS.
I don't know so the long one for tag A would be tag all. It shows all files and directories. And yeah, so LS, pretty simple. Tag L gives more detailed, a more detailed view of the files. So you can see right here on the bottom, there's, we go more into this, but it's like permissions and then hard links. I won't go into much about that. We have users group right here. Then you have your file size and then the date it was last modified and then the name of the file. As for creating files, you can use the touch command, which is also pretty simple. You just type touch and then the file name. But you can also create a file with a text editor. We'll go more into that later, but it's pretty much the same thing as touch, except you can edit the file. Right. And then for commands, like basic commands, you have your copy. It's, just the way it works is you type CP and then the path of the file you want to copy. No, the original file. And then the second argument is where you want the copied file to go to. It's also a good way to rename. You can also rename the file when you copy it. But there's also the move command, which pretty much does the same thing as copy. But instead of making a copy, it actually moves it. It's also, the move command is also used to rename certain files. And then we have cat or concatenate, which lists the contents of a file. That's pretty simple. And then remove, deletes the file. It's not specific to a file. It's also, you can also use the command to delete directories. There's a set of flags you have to put in order to delete a directory. But maybe you can find that out yourself. I think it's RF. Actually, never mind, it's right there. So it'd be the tag R. So it'd be remove, then tag R, then tag F. That one's to remove all content, or tag R is to remove all contents and subdirectories in a directory. So basically delete everything inside. And then force is just to, I don't know, remove it without being like prompted to say no or whatever. And then make directory, you can make directories, pretty simple. Right, let me grab some water. All right, so some Linux sysadmin stuff. Before I go into like other like permissions, users, and other stuff, I think it's a good knowledge to know about where you get these commands from. As I mentioned before, it was in that sbin and bin directory in the user directory. But in order for us to access those directories, we have the path variable. So this is basically a string that lists all the directories to look for when you type in the command. So if you type in ls, it'll go to each of these directories and look for the executable to actually run that command. And if it's not there, then no, you gotta add it somehow. But usually, yeah, it'll look for everything in these directories. So then they're separated by a semicolon. It's kind of hard to read the first time, but you have your full path or your absolute path here. And then it's separated by a semicolon, and then is your next path. So something just to watch out. Then for aliases, basically an extension to the path variable, but more, you can customize how you want to output a command. So then you see right here, if you type in ls, it actually runs a flag with ls, so then it'll give it that color. But you can also add your own alias, which I did right here. If I type CCDC, it will print out CCDC, and it's more for like convenience sake, I would say. And if you want to make things faster and not always put in a shortcut, or not put flags every time you use a command, you can just use aliases to make a shortcut for that. And then strings. So first we'll talk about file editors. First here, the first one we have here is Nano. It's it's a more basic file editor, I would say. Your Vim is next, don't worry. But Nano is mostly installed on, I think, most distributions. And it's kind of like your Notepad equivalent kind of thing. There is like one shortcut or one like keybind you have to do to exit and save, which is Control X. And then when you're prompted to save, you have to type Y. But other than that, it's pretty simple, pretty straightforward. Besides, or compared to Vim, pretty notorious for being complex, complicated, skill issue, I don't know. But Vim, it's definitely more hoops to jump over to use it. It's more focused on like key bindings and shortcuts. That's why it makes it like super customizable. You can add plugins, different settings, and different keybinds for your needs. But it also has like the two main modes that it uses are normal mode and insert mode. So normal mode is more for like navigating. Yeah, it's more for navigating, kind of like deleting, or not deleting, but like more, just for navigating. And then insert mode is for actual like text editing. So in order to enter insert mode, you have to type, or you have to press I. And then if you notice, if you ever go into Vim and you press I, it'll show you that you're in insert mode. And then in order to get out of insert mode, or any mode actually, you have to press the escape key. It's kind of like always, whenever I'm using Vim, always like spam the escape key. It's kind of like a manual car, I don't know if anyone would get that, but like, manual car, you have to be in neutral. Anyways, yeah, so that's kind of like the hard part, knowing which mode you're using. There's also like different modes. There's command mode and visual mode. You can look into that more, but the two main ones that we use, or most people use, is the normal mode and insert mode. If you ever get stuck, you can always use the Vim tutor. It's a document you can read up on the terminal and how to use Vim. But I'll leave that to you to learn. And then we have sed, which is not a text editor. It's another command to manipulate strings in a file.
So sed is very useful when you're doing stuff like scripting, since, well, it takes in inputs. It's a single command and it can take in inputs, usually regex, and modify the file that you want, sometimes in place, sometimes not. It depends on whatever version you're doing. Yeah. It is very powerful it's very powerful if you know what you want to change and what you want to change it to. Especially if you want to mass propagate it across a bunch of different things, you could throw it into a script. Yeah, it's very powerful. And at the bottom, we can see a couple examples. Let's see. The first one's replacing the first instance of fox with dog. The next one's replacing the first instance of dog with wolf. And then the last one is replacing all instances of the with a.
Thank you. All right, so then moving away from text editors and sed, we also have standard input and standard output. I'll start with standard output because we might have a better idea of what it will do. So it's more for whatever a command outputs. So let's say you do an ls on a directory, and whatever comes out is that's the output. So you can use that output to redirect it to, let's say, a file. So you can see down here. I output hello from Texas. And then if you didn't have like this second part here, it will just output it on the terminal. But with this greater than symbol or the standard out character, you can direct this output or the echo output to a file. And you can see right here, that's what it exactly did. As for standard in, it's basically the reverse. So whatever's in this file, I know this is kind of like redundant and kind of like, why would you do that? But for example's sake, example1.txt had a string inside, and then I redirect that into a cat, and then it output that. So then moving away from these two, we have pipes. Pipes is used it uses the output of a command, and that output is being used for another command. So then the symbol here is that it's actually called a pipe command character. I thought we called something else, but yeah, it's called a pipe character. But the example here is cat, you're outputting this favorite things.txt, and then I'm using that pipe to send that output to the sort command, which will sort it out alphabetically. If I didn't have that pipe sort, those two components, it will just output wherever the file is. But with the pipe and sort, it'll grab that output and sort it. Pipes are pretty useful in sysadmin stuff, you can have like a long line of pipes and just to do, it's really useful for like one-liner commands, and yeah. And then file permissions, as I mentioned earlier with the ls tag L, there was that one section where it had these weird characters and dashes. That's where I said the file permissions were. So then that first part of the ls indicates what kind of file it is. So the D stands for directory. Let me check something. When it's like a normal file, it's just something else, right? When you ls out.
Oh, yeah, let's like how shows you.
Okay, yeah. So if it's just a normal file, it'll just be a tag. But hey, if it's a directory, there's other ones, but I'm not gonna go into that. And then we have your file permissions. You have your user, groups, and then other. I'll go more into, or the user is just like a singular user. Then groups are just like a collection of users. So each of them can have like different file permissions. And then others kind of, yeah, it's basically anyone else. So if you're not a user and you're not part of the group, you'll fall into other. And then for file permissions, you only have read, write, and execute. So there's two ways to read file permissions. The ones I just explained here, the read, write, and execute. But there's also a octal or numbering system they could use. So then that's where I have these values right here. So then X, sits on the 0 part, or X has like a value of 1, and then W has 2, and read has 4. So then any values between 0 and 7 will determine like how these file permissions are set. And you might have to do some math. It's not too hard, but sometimes I struggle as well. But just for example, I mentioned earlier that this is 4, 2, 1. So to convert this whole row, wait, is there a pen? I can draw. Oh, yes. Oh, wait, I can't do it. Oh my God. Okay. Shift A. Okay. So this one right here would be like 4, 2, 1. So quick math, 7. And then here would be 4 and 1. So it'd be 5. And then it's another 5. Yeah. So then I'll do this one real quick. So then 6 would be like a 4 and 2. So it'd be read, write, and then 4 would just be read. And then maybe if someone in the chat or in the room wants to do this one right here, maybe some participation, yes. So if some people already got it, it'll be a 5, 2, 1. Do some math, and then I think this one would be pretty easy. Yes. So be W, or RWX and then RWX and so on. Then as for changing permissions, you use the chmod, or stands for, never mind. The it changes permissions. So there's two ways you can use it. It's with the octal or the letters, the RWX. So here you can see it's using, it's using the octal right here. So chmod 777, which is all of them being enabled. Or you can use the chmod and then what's the A? So let's say if you want to change the user permissions, you would do like a U and then plus and then whatever permission you want to use. But you can also do the same. It can also be like U minus, right? So then here. So the A here is, it applies it to all of them. And then this one is just only for group and other. So then you can see right here, they can only read, and 7 is all of them. So yeah. Then we also have the chown or chown, which changes the owner of the file. We have the syntax for it is always the user first here, and then separated by semicolon is the group. So, and then after that is the file. So pretty simple to use. Like I said, user right here and group, good way to check if those commands actually worked for you or not. And then we have a different set of file permissions, or not really file permissions, but they're similar. They're called attributes. It describes how a file should behave. So there's different flags you can use to set like how a file should interact or behave. But the most notable one that we've seen is immutability, which doesn't, users can't like modify it, rename it. Basically, users can't touch it or do anything to it. Only the super or the root user can remove the attribute and basically make it turn back to a normal file. But to use these attributes, we have the chatter command, which changes the attributes, kind of the same as chmod. Change attribute, you can add the immutability to a file, so it'll be an I. And then to check on the attribute, you can use ls-adder and then the file, and then you could, usually it looks like this right here. It's a really long line, and then there's like several bits or several attributes that are being set already. And then to remove it, it's similar to how you add it, but with a minus sign. And yeah. And then I mentioned earlier about users and groups. The root user, or there's always, each user has an ID which is used for processes and keeping track of like users besides using their names. So for root, has a UID or user ID of 0. It's the big boss. The root has special permissions that no other user has. So you should be careful when you use it, but I still use it. And then service users, their UIDs are always less than 10,000. And then for your normal users, they're always greater than 999. The first user account that you create or you use is usually like 10,000, like 1,000. There is an exception with services UIDs being less than 1,000, and that is the nobody user, which has an UID, I think it's like 60,000 or something. It's usually not less than 1,000. It's around like 10,000 or something, but that's the only exception that I've seen so far. And then I mentioned that it might be a bad idea to use the root account to do like your daily operations, but there's also a way. There are certain commands that you need admin access to, so that's when you use the sudo command. It gives you temporary like privileges. It's basically the same thing as a run as admin in Windows, but yeah, if you do like a sudo and then a command, it gives you like root privileges kind of to use that command, and then yeah, that's how you use for like admin and high privilege operations. There's also the SU, like I mentioned, you can still, nothing's stopping you from accessing the root account, except a password maybe, but not for us. SU stands for switch user. It's not just for switching to the root user, you can also use it to switch to other accounts, and you might need to use that if you have different accounts, but yeah. And then talking about users, how can we add more users? It's another simple one. Depends which one you use. There's add user, which it's a more efficient way to add a user. It just asks for like a name, password. Yeah, like I don't know why I asked for your phone number, but like yeah. So if you want to add a user, you just do like add user and then their username, and then you'll be prompted. You just follow the prompts, and that's how you add a user. But then there's the user add command. This one's a little tricky, or it's less efficient and less efficient and takes more time. Basically, you have to use different flags to like set up the user. So like if you want to make it have a password and have a username and all that stuff, you have to type it all out. You have to manually set up everything for that user. Maybe you want to use it when you want to create a user that's more like customizable, but usually if you just want to create a user, add user is the way. Yep, it does everything that user add does, but you don't have to do any work. And as for managing users, like I said earlier, you have users, but you also have groups. And groups, as I mentioned, also are collection of users. So they have different. So then when I go back to the file permissions, it's always, it looks for the user permission, and if that doesn't work, it goes into the group permission and checks if you're like in that group, then it'll fall under that group permission. But for like adding users to a group, that's where you use a user mod or user modification command. That's where mostly I use it for adding like a user to like the sudo group, which allows people to use the sudo command. So to do that, it would be like user mod, and then it's like tac a something. Yeah, lowercase a and uppercase G, and then you just do like the group and then the username. And then to view like groups and users, you can use the ID command to view like the UID of a user and like what group they're part of. It's just to list everything about, not everything about that user, but like the UID and group ID of that user. And then as for passwords, there's two different commands you can use for passwords. Oh my God, I need water. So the first command is passwd or password. To change it for your current user, you just type passwd, and then it'll prompt you to enter a password. You might notice that when you type a password, there's no characters that pop up. Totally normal. Just keep typing your password, and if it's not right, then it's not right. You gotta type it again. Unfortunately. But if you want to change a password for a user, you just type password and then the username, and then it will change it for that password. It might require sudo, so keep that in mind. And then for another password is, the other password command is chpassword. Is mostly used for automation. And you can see right here, actually in the image, you can see that, yeah. Oh, this one is interesting too.
For change password, there's two ways of using it. If you're planning on scripting stuff out, then you're more likely to use the latter. So at the very bottom, you can see the example where I'm echoing user2 : cool into change password. And so what that does is it changes user2's password into cool. Just know that while you are putting stuff in plain text, so you do have to keep that in mind. The other way is to just run change password. And then you're using the same format as the bottom example, but once you're done, you press enter, and then you press Control D to finish it off. Control D is end of file, I believe, and that just tells change password that you're done editing it. Otherwise, you'll be stuck in it, and if you press Control C, you'll just cancel anything you do. So.
Yeah. Then moving away from users and groups, we're going to talk about processes. Processes are just basically like programs or jobs that run on a computer. These processes could be like automatically generated from the system, but they can also be created from like the user. So let's say like you open the terminal, that's one process, and then there's other like commands that you run that count as a process. But in order to see like the full list of processes that are running on your system, use the PS command. That basically takes a screenshot of the processes when you type in the command and then outputs it to the terminal. There's also PS aux, you might have seen it. That's a more in-depth screenshot of the processes. So all of the processes from all users, makes it look nice too. You can see which user started that process. And as for terminating processes, you use the kill command or pkill. I'll go with, usually I use kill, and then the TAC9 is just like yeah, it's a signal that tells it to die. I mean, to terminate.
Just to terminate.
Yeah. So then it'd be like kill TAC9, so it means to terminate, and then you'll see when you use the PS command that each process has a process ID or PID. So you just find the PID and then it'll kill that command or kill that process. But there's also pkill, which I guess is more broad or not as specific as kill, which for pkill you use the service name. Yeah, you use the service name as the identifier to terminate the process. And then there's also pgrep, which finds the PID of a process by the name of the process. So if I did like pkill or pgrep and then like SSHD or something, it'll give me the process of SSH or the PID of the SSH. And then moving on to services. Services are processes as well, but they're more like application kind of. They're more like applications. They serve a specific purpose or have a specific feature to the system. So when you manage services, there's several ways or 3 ways to manage them. You have system CTL. Oh. First, you have system CTL. That's the most used one in most distros. It's pretty simple. You have system CTL, and then you have the different arguments that it can accept. There's status, start, enable, restart, stop. And then you have the service name. It might be a little tricky to find the service name, but you'll get there eventually. I usually like to use system CTL status is definitely, or system CTL status gives the log view and also like different information about it. So it's pretty great for troubleshooting. And then you have the service command. So it's like an older version of system CTL. I usually use that command when system CTL isn't there. Yep. And then the syntax is kind of switched around. So it'd be service and then the service name and then the argument you want to do. So it'd be like status, start, and I think restart as well. But it's not as verbose as system CTL. If you ever run this command service, if you run the status command, it just says that it's on. It's not really that helpful for like troubleshooting, and probably use it as a last resort. And there's also rc.d or init.d. This one is more like it's like running running a script, yeah. So like you can see right here is like the full path to that script, and then there's like it expects like several arguments like here, but the hard part is like finding the location. And I'd rather just type one of these to find or to start the service up or something. But this is also like very, very last resort. Maybe, yeah. Then moving to distros. In the beginning, I mentioned there's different distributions. Here we're talking about packages. Packages, they're ways to download applications and software. First, we have the Debian base, which uses the apt or apt, and then update. What update does is it looks for the repositories of. So how packages work is when it looks for a package, it goes to a list of repositories, which is hosted by like Debian or Red Hat, and it will go to those repositories and look for the packages online, and then it will download those packages from that repository and install it on your system. So what update does is actually it updates that list of repositories, or updates that list of repositories. And then upgrade is more for updating your applications on the system, to the newest version or whatever. Usually this one takes the longest, but yeah. And then install is where you install your packages. You can specify multiple packages by just like typing one package and then space and another package. And then we have purge or remove. I don't know. I think mostly use purge to like remove like. Yeah. So it'd be like removing the program itself from the system, but also removing like the files that it created or the service that the application, the files that the application created or like configurations that it created. And then every other distro uses like the same thing, but there's like slightly different. So RHEL or Red Hat, pretty much the same, or except for the yum. I don't know why it's yum, but yeah. And then you have other distros. I think APK is Alpine, the Alpine distro. Pacman is Arch Linux, and Solaris is, I think it's Oracle, right? Oracle, Solaris. Yeah. Marshall says it's horrible, so I don't know. But usually you use like one of these two, unless you're an Arch Linux user. This slide is kind of extra commands. And you have the man pages, which is the manual for each command. So if you want to access the manual of ls, you do like man and then that command. So ls man, what? It would be man and then a command. So let's say man ls. So your full documentation on that command. But there's also like the tac help, which is a shorter version of that command. It's for something that's quick. And easy to find the flags. And then there's the find and grep command. Find is to search for file names, mostly to see if it exists or not. And then grep is to find strings in a file. There's less or more. It's like the cat command, but you can scroll head or tails, and it gives like the first 15 lines of a file, and then tail gives the last 15 or whatever number you set. And then the last one is tmux. it's most of the time it doesn't come with or it's not natively, or it's not already installed in most systems. You have to install it yourself, but it's a command that, yeah, a terminal multiplexer. So you can use that command to create more windows or panes of a terminal. Yep, okay. It's very useful, especially when you're multitasking, especially in in a server environment where you can't have multiple windows or tabs of a terminal. So you can see right here how like it would look. You have one window here and two more windows here, and then to use tmux, there's more shortcuts you have to learn. To switch around, or for starters, you have to, every time you want to use a tmux shortcut, you have to do Control B, and then after that you have to quickly put like a keybind, or not keybind, but it's another like a shortcut. So then if I want to move between panes, it'll be Control B and then like arrow key to move left or right to the pane. Just a few like shortcuts here that I put on. So like you can split each pane. So like right here, you can split it horizontally. So it'd be Control B and then double quotes, and it'll split it horizontally and do it vertically and all that stuff. It takes time to learn. I know it took me a minute to learn, but once you get a hang of it, it's pretty good. And then there's just some Linux tips. Yeah, I'm not gonna go through all of them. You can look at them, stare at it, study it. I don't know, but I'll give it to Marshall now for, yeah.
So next we'll be going over some Linux security and more Linux-oriented networking, in quotes. You'll see why. So first is stuff related to user management, specifically files. We have etc password, etc group, etc shadow, and etc sudoers. So first, etc password. etc password, etc password pretty much shows you all of the users on the system, along with other information that's related to them. So there's stuff like their username, the user and group IDs, any random comments, their home directory, and what shell they'll use whenever you say authenticate using SSH or just straight up through the terminal. Password here isn't actually used in the etc password file, and that's because it's a remnant from an older time when password used to actually be stored in password, but now it's stored in the etc shadow, which we'll cover, I believe, afterwards. It's somewhere here. Oh yeah, and this is what the actual etc password looks like. Next is etc group. It follows a very similar format. The username, actually, yeah, sorry. The name of the group, password as well, the group ID, and then the members of said group. Next, we have etc shadow, and etc shadow is where password hashes for users are stored. So again, we have the username, the hash of the password of that user, along with a bunch of other miscellaneous information like the last time the password was changed, the minimum time between password changes, and the amount of days the password is valid. Finally, but just as important, is the etc sudoers file. This describes, well, this config describes what sudo can do, who can use sudo, what commands they can run, who they can run it as, etc. I believe this is just a blank etc sudoers file, and yeah, it's a blank default etc sudoers file. So group can obviously do any sort of sudo actions. Meanwhile, if you're part of either the admin group or the sudo group, you can also do any sort of actions. You can specify it to be something like no password, so they can just run sudo without a password. You can specify the binaries that they can run. You can specify who they can use sudo as, which you would have to then specify using the attack U flag. There's a bunch of things you can do with the sudoers file, but it describes what sudo can do. Next is the pluggable authentication module, or PAM. This set of configs really just manages a lot of the authentication. There's a lot of stuff with PAM that I'm not too familiar with, but the important things, or at least one of the most important files that is part of PAM, is common auth or system auth and password auth if you're in a rel-based system. These dictate pretty much all authentication, whether that be through console or through SSH. Here's an example of common auth. So what this is doing at the very top is it's handling password authentication. That pamunix.so file handles, I believe, standard password authentication. And so when you attempt to authenticate using SSH, if you get the right password, you'll succeed. And the next line, the pam_deny.so, will get ignored. However, if you fail your password authentication, there's no setting for failure, so it defaults to ignore, which means the next line, the pam_deny.so, happens and your authentication gets denied. So something interesting you can do with this, say as a red teamer, is modify their default rule. Since there's no explanation of what happens, or since there's no explicit rule for what happens when this thing fails, if you modify the default to something like a 1, then what happens is whether they get the password correct or not, they'll authenticate. Really? That's crazy. I did not add permissions to this. Yeah, do a request. Oh, that's crazy. Did I not? Here, 1 second. It should be fine. I just need to find the file. I'm not gonna find it in a fast amount of time. Camps, drive. Yeah, sorry about this. It seems like there's some file permissions. Funny stuff. For share. Allow anyone. Share. Allow anyone. You might need a refresh or. Okay, cool. Yeah, right. So yeah, let's see. For this example, we have someone trying to use the sudo command. Obviously, they're just typing a random password. I don't even remember what I typed. I'm pretty sure I just keyboard mashed. And obviously, that's not going to be the right password. However, on the right side, I'm now going to do exactly what I said. I'm going to modify the PAM file, the common auth file, to have the default be 1. So if it fails, it'll go to the default, and default will now be 1, just like success. So it'll essentially treat the failed authentication as a success. And as expected, with a random keyboard mash, we are now root. So yeah, that's why PAM is quite important to know about, especially if it gets backdoored. Next, we're going to be going over some random Linux networking things. It won't be as in-depth as last week, since that was actually for networking. This is more stuff related to IP, the service that runs your network stuff, et cetera, et cetera. So first is Network Manager, which is a service that manages your network connections. There are a bunch of different services that can do this. Network Manager is a very common one on something like Debian or RHEL, though there's also systemd networkd, which I think is default in Ubuntu. I might have gotten them wrong, but these are the two that are pretty common. Yeah, it manages your network connections. And if you have an error, and you might think it's red team, you might want to check this just in case they've turned it off. Though that would cut them off. It would also cut you off from having any internet, which isn't good for your company. Next is just your general network connections. If you don't know what your own IP is, you can get it through stuff like IPA, ipconfig, ifconfig. It really depends. I believe all of these should work. It just, if you don't have one of them, try another one. And now if you want to actually view any network connections, you can use something like netstat or SS. While I prefer netstat, it's usually not on systems by default for some reason. You need to install the nettools repo. So SS works and it has pretty similar command syntax. As you can see on that example there, SS toolpin, I believe that just shows you a bunch of the established and waiting connections. Anything that's listening shows you all of them. So there's stuff like local DNS, SSH, something running on 8080, and we can see both of them output pretty similar things, just in different formats. Next is Nmap, and Nmap again is a very useful tool. It's just a network mapper, so if used externally, you can see what open ports you have. This is really good to know your attack surface and to quickly find anything that's running that's externally accessible. And so finally, we're just going to be covering some more firewall stuff, but this time for Linux, because I believe last week was more oriented towards Windows. This one is going to be more for Linux. So why exactly do we want a firewall? Well, the more open ports you have, the larger your attack surface. Obviously, if you have everything open, that means anyone can connect to one of those ports, and if you don't realize that, and you run something insecure on one of them, it could just be open. So yeah, with firewalls, they should really work on an implicit deny principle. What that means is you have to specifically allow things in, anything else gets blocked. And a very powerful Linux firewall tool is IP tables. There's stuff like UFW, but that's pretty much just a wrapper for IP tables, I believe. But IP tables gives you a lot more fine-grained control. It's a bit more complicated, but once you understand it, it's very powerful. IP tables works off of chains. Chains are essentially just a list of rules. It follows the rules in order from top down, and if nothing matches, it follows the default policy. For IP tables, there are really three main chains: input, forward, and output. Though you can add your own chain if you want to, and this is important if you want to do some weird network logging. But generally speaking, you're just going to be using the default three chains. To set the policies, the default policies, which again, default policies are what happens when no rules of the chain match. Use IP tables tac policy or IP tables tac capital P. Then you specify which chain you want to change the policy for, and then you specify either drop or accept. If you want to clear all of your rules, you can do IP tables tac F. If you want to list all of your rules, you can do IP tables tac L. Normally, I like to combine this with IP tables tac L and then tac N as well, so that you're not doing any DNS resolution. This just makes the command run a lot quicker, especially if you're in a high stakes environment like a competition. So let's go on an example. Say you have a web server running, it's running some random web app on port 80, and you want people to only have access to that port. What you can do is use IP tables to filter out any traffic that does not go to port 80. So at the very top, you want to modify your input chain, since that's what happens, since input is where traffic goes when it comes from the outside in. So IP tables tac A. Tac A specifies, or means you're specifying the input chain. Then you want to specify the protocol with tac P. It's TCP, since that's what HTTP runs on. Then you want to specify the destination port, the port that external traffic will get to. So that'll be port 80, since we're just doing HTTP, not HTTPS. Finally, we want to tell the traffic what to do if it matches this rule. with a jump statement, which is the TAC J. Not exactly sure why it's called TAC J. I believe I did read something about it, but I can't remember at the moment. But yeah, we want to accept any traffic that matches this rule, so we accept it. Anything else, we want to drop it. And by that, we are going to just modify the policy, the default policy for input chain to be a drop, just like before. Next, a bit more complicated, we want to allow outgoing responsive connections. So IP tables by default is not stateful. I believe we went over this before, but because it's not stateful, it's not going to track what's coming in and what's coming out. So if it allows traffic in, it doesn't care about whether or not that traffic can go out. It'll only allow it if another rule, if it matches another rule. However, you can kind of make IP tables a bit stateful by using a specific module known as contract or connection tracking. So using this module, we can modify the output chain. Again, we want to do TCP. We want to specify the module through TAC-M contract. And then we want to do a CT state or a connection tracking state. I'm not too sure. But we want to make sure that any established or related connections will be allowed outbound. Since if we're letting something in through port 80, it'll be an established connection and we want to let it out. And then of course, we do a TAC-J accept to allow that traffic. And then similar to the input chain, we want to deny anything else that does not match. Here's another video example. I kind of recorded these after the SDC died because I wasn't sure if I would have a live demo. But this one's a little bit different. It's quite similar to the last one, or at least quite similar to the example I had before, but I don't think I go over the contract module. But yeah, do an IPA to figure out the IP of the machine. And then externally, I do an Nmap scan, and we can see, well, there's FTP open, SSH open, and HTTP. I don't want this. I believe all I want is port 80. And so I list our IP table rules through IP tables TAC-L and again, TAC-N, and it's empty. So what do? We create new rules. First, I'm allowing 22, allowing anything in on 22, just because I want to keep this SSH session open, and if I don't have this rule, I will get kicked out. Next, I believe I do, oh, actually, the only thing I'm doing is allowing SSH. Next, I change the policy to drop anything that does not match this rule. And so now, if I check IP tables, we can see there's only one rule, and there is a deny policy. The one rule is allowing 22 in, and we're blocking anything else, or rather dropping any other traffic. And now if I do an Nmap scan, it's going to take a bit more time. We can see that the only port that's open is 22, which was what was expected because of our IP tables rule. Oh, that's crazy.
Right. Thank you, Marshall. That's basically what we have to cover for today. All of that 90 minutes. There's definitely more stuff to cover, but you'll learn more as you go. And as for lab, we're going to be using the SAT servers website. It's kind of like if you were in if you use over the wire bandit, it's the same concept, but I think it's more sysadmin, and it looks different. So if you can, this will also be part of your homework. So make sure you do it. We do have another document for homework, but we'll release that later.
Also, one more thing, I talked about this during CPTC. We have fixed an issue that happened with Camino where whenever you deleted one pod, it deleted all of them. That's because it was linked to your username instead of your tag. But anyways, regardless, if you have any pods that you are no longer using, please make sure to delete them so that we have enough IPs for your machines. I I think I saw earlier today, we were at like 120 IPs out of 200 allocated. Which was quite impressive to see, especially after we had to purge a lot of the pods. But that being said, please delete any of them that you don't need anymore so that we have more space.
So I guess for the rest of the time, we'll be working on these labs on your own. If you need help, just DM me or Marshall or put in the chat. But yeah, register an account, and then you go into the scenarios part. Sure, I could. Yeah, so the ones that we chose do require an account. So, it'll be like this one. No, it asks for an account, but when you run, it'll start to build the level, and then you only give they only give you like 15 minutes before the connection cuts out. So you could spin it up again if you don't get the answer. But yeah, you could check the answer, just there'll be a check answer here. But make sure to document everything and take a screenshot of like the completion, and yep. So you can get started now.